We're going to go over graphing our tangent, graphing trig and trig reciprocals. But that thing is funny, so confused. I'm going to go a little slower now. So our tangent function, one way to look at it, okay, is it does have asymptotes, okay, throughout this whole function. So those asymptotes are actually going to occur at, in terms of degrees, are 90 degrees would be our first one. And then from there, what happens is it takes 180 degrees for the next one to occur. Okay, so in other words, really we could go from negative 90 to positive 90, which is 180 degrees. Think of it like that. Okay. Then from there, it takes another 180 degrees. Okay, so 180 degrees will give us that 270, which is also the equivalent of 3 pi over 2. Okay, and then again at 5 pi over 2. And then in the reverse idea, we're at negative 3 pi over 2. Well, it wasn't quite on the line. And negative 5 pi over 2. So we have our asymptotes for tangent. The other thing we kind of want you to know is that in between them, so the very first one would be at 0, it's going to cross the x-axis. Okay? And then again, 180 degrees to the left and right of it, it's going to cross the x-axis again. So in other words, at pi or 180, 2 pi, 360, it's always crossing the x-intercepts there. Okay? And there, from there, it kind of looks similar to your cubic functions. Okay? An original cubic function that hasn't really shifted. Think of it like it's going up, cuts across, and then heads up again. Okay? This pattern continues. I'm going to try to draw my best, especially as the computer's lagging a little here. Comes through and goes up. Now you could plug in values for tangent to find out what these exact points are if you want. Like what is it at 120 degrees, 160 degrees. But this is the general idea of what it's going to look like. Okay, so here's our tangent. Draw the best we can. And finally. Okay. So those are our tangent functions, or our examples of them. Now, our cotangent, the reciprocal of that is going to be a little bit different. What you're going to notice is our asymptotes for cotangent, this was a tangent, tan x is equal to y. Our cotangent, which we'll do in blue, y equals cotangent x. Our asymptotes are going to occur where the original tan zeros are. So the tan zeros being at 2 pi, pi, 0, negative pi, 2 pi. Those are the new asymptotes, okay? And we'll draw them in blue. Okay? So our new asymptotes are actually occurring where the zeros of tan were. So in other words, if you can draw tan, you can figure out where the new asymptotes are. Okay? They fall in between the old asymptotes, right down the middle. So I'll draw them quickly. The computer's going to lag a bit, but we'll do our best here. And then from there, what's going to happen is our cotangent is actually the reverse direction of our tangents, okay? So the asymptotes of our tangents are the new zeros, you could say. So for instance, remember our asymptote here at negative pi for original tangent? That's actually going to be the 0 for the cotangent. So all of the old asymptotes, I know it's looking a little confusing because so much is drawn here, but the asymptotes that were in black are the new zeros, okay? Those are the new zeros. The blue ones are our asymptotes. And they actually go in the reverse direction of our tangent. So remember our tangents, we went from left on the bottom and then up to the right. We're going from up on the left down to the right. So in other words, because this is an asymptote, okay, and that's another asymptote, just trying to get you to focus. It goes down, cuts through that 0, and then comes back down again, never touching the asymptote. So these are our cotangents. Okay, it goes down. Not the easiest to see. I'm going to try to jump over a little. But that's the general idea of how to draw it from the original guy. Okay, and this guy would go like that and cut across. And this guy would actually be coming down like that. Okay, so the blue ones are our cotangent. It looks pretty confusing. Kind of looks neat to look at. But the blue ones are our cotangent x. Now, what they've done is they've shifted something for us in this question. So we're going to put it on a new page. And it looks like what they've given us is cotangent has been horizontally stretched. Yeah, we have a horizontal stretch. The question now says cotangent of x divided by 2, is it? Divided by 2. Okay, well, what we want to do, again, remember we always want it to be in the form of f at x is equal to a, whatever the function is, k, x minus d plus c. That's all going to fit in, I think, in a second. Smart those computers out. That being our function. Our function is our cotangent. So, again, we want our coefficient in front of x to be 1. In this case, it's actually a half. So we're going to factor out the half. Y becomes cotangent a half x. Okay? So we have a half x. In other words, just our k value. Okay? So a period, if you recall, the period with the tangent happened how often?
With the tangent?
Mm-hmm. Pi.
Yeah,
it happened at every pi. So period was at pi. It was 180 degrees, if you recall. Okay? So what we're going to do now is we're going to divide by a half, or 0.5, you could say, right? So we'll divide pi by a half. What is that going to give us? We just talked about what happens to it. 2. It becomes 2 pi. Okay? So all that's done is it's stretching horizontally our cotangents. Okay? So we'll originally draw our cotangents again. Hopefully from memory, we're very good with them. We'll get our graph up here. I know the computer's going slow. Okay. We'll draw our original cotangents. Let's see if we can remember them from memory. Our asymptotes for the cotangent, do you remember where they were?
Pi? No.
Those were tangent.
90?
90 is where...
90 to 90 is the original.
Original tan. So it would be halfway between that.
It's 0.
0 is 1. And then they occur every how long?
Pi.
Every pi, exactly. So these are our original cotangents. Good. Okay, these are the asymptotes to the original cotangent. And if you recall, the zeros were where the tangent asymptotes were. So in other words, at negative 3 pi, at negative pi, at pi, 3 pi over 2, those were them. And what was actually happening is they're going up from the left down to the right. Mm-hmm. Right, so there's our cotangents. They kind of go like that. Well, what's happened now? What happened to these asymptotes? Are they occurring at the same points? No. They're occurring how often? Pi? Every 2 pi. Okay. So our new asymptotes, we'll do them in red. It's still at 0. Okay, so we still have one at 0, but instead of recurring at pi, it happens at 2 pi. Every 2 pi, right? Like we said. So the other one is going to be drawn here. And then the easiest way to really think about it is halfway between that will be our 0. Okay? So our 0 in this case is going to be at pi. And it's going to come down and be a little... Oh, that's not very good. Let's try that again. It's going to come down and cross and reach all the way to here. Okay? So it's occurring half as much. Okay? So not as likely. Again, here at negative pi is our other 0. That's halfway between it. It comes down from the left, cuts across, and goes back down. So those are our new ones. In other words, our red function is the idea of that cotangent of pi divided by 2. So it is reoccurring twice as unlikely.